A short bar magnet placed in a horizontal plane has its axis aligned along the magnetic north-south direction. First I prepare the figure. Data ઓછા થાય એટલા માટે હું દોરી રાખું છું. So this is the magnetic field, earth magnetic field. આજે બતાવ્યું છે earth magnetic field છે. And this side north and this is south way. So magnet to magnetic field આવી રીતે હશે. Sorry, I take down north and this is south. So magnetic field આવી રીતે જાય, આવી રીતે થશે. તો જ એક્સિસ ઉપર તમને નલ પોઈન્ટ મળશે. કેમ? Why? So because this is the magnetic field of the magnet, red line, and this blue line is magnetic field of the earth. Both are opposite, so you get the zero magnetic field on the axis. So it is only possible on the axis if magnet is placed like this. North is down, south is up, means not toward the south of the earth. So when earth magnetic field is equal to magnetic field of magnet, then we get null point. Then we get null point. Okay. So here null point is at 14 centimeter. Using formula B on the axis is equal to B of the earth is equal to mu 0 upon 4 pi 2m upon dq. This is the magnetic field on the axis is equal to. Okay, so we don't need to calculate this m. Otherwise I can calculate m also, where B A is equal to 0.36 cos. Earth to magnetic field. We can calculate magnetic moment of this magnet, but any there જરૂર નથી એટલે I don't do calculation for that. હવે એમ કહે છે what is the total magnetic field on the normal bisector? તો આ normal bisector એટલા distance છે at the point 14 centimeter. અહીંયા ધારો કે 14 centimeter થાય. So what is the magnetic field? So we have two magnetic field at the same time. One is because of the earth and other one is because of the magnet. Both are in the same direction, so it is a double. So this is 14 centimeter, right? બરાબર છે. તો એ આપણે કેલ્ક્યુલેટ કરી નાખી 14 સેન્ટીમીટર કેટલું થાય. So magnetic field, magnetic field on equatorial line. એની આપણી ફોર્મ્યુલા શું છે? BE is equal to mu 0 upon 4 pi m upon dq. Distance is same, so I write d only. So this is nothing but 2 times I can write okay, this is BE, but what you can write mu 0 upon 4 m upon dq બરાબર શું લખે? BE by 2. So BE by 2. So what is the magnetic field of the BE? That is 0.36 divided by 2. So it is 0.18 Gauss. It is in Gauss, huh? It is in Gauss. જો હું આ બધા SI સિસ્ટમ રાખું તો મને ટ્રસ્ટ લાવજો, પણ અહીંયા તે જરૂર નથી, so I don't use it. So 0.18 Gauss. This is red line. And what is the blue line? 0.36 Gauss. So total resultant magnetic field, at that point is equal to B because of the earth and because of the magnetic field of the magnet on the equatorial line. So 0.36 plus 0.18, so you get 0.54 cos. So this is our answer. 0.54 cos is our answer. Okay. If the bar magnet is in this exercise is turned around by 180 degree, where will be the new null point? Okay. So in this situation, north is down, south is up. So I turn, so south is down, north is up. તો શું થશે હવે? So this is my magnet. This is your south. This is your north. So magnetic field line like this. Okay. And earth magnetic field is here. Sorry. Earth magnetic field in upper direction. I drew few lines. So now we get null point on the equatorial line because both are opposite. Our null point क्या મળશે? On equatorial line. So I have to use the formula of the equatorial line. So when magnet is turned around by 180 degree, the null point will be on equatorial line where magnetic field where magnetic field is magnetic field of earth is magnetic field of magnet is 0.36 Gauss. So BE is equal to mu 0 upon 4 pi m upon d cube. I take prime. Okay. So this is we get this is 0.36 in terms of Gauss is equal to mu 0 upon 4 pi m upon d prime cube. Okay. But same field where we are getting? So mu 0 upon 4 pi m 2m upon d cube. Here m upon d prime cube, here 2m upon d prime cube. So this is cancel. So what is my d prime cube? So d prime cube is equal to d cube by 2. And so we get d prime is equal to d upon 2 raised to 1/3. So d, it was 14 and divided by 2 raised to 1/3, you are getting 1.26 around. So if you do calculate around, it comes to 11.1 centimeter. And આમે તમારે યાદ રાખવાનું થાય કે મેગ્નેટ મારું હોય તો આ જે બે ડિસ્ટન્સ છે મને મેગ્નેટિક ફિલ્ડ સેમ થાય. અહીંનું મેગ્નેટિક ફિલ્ડ એક્સિસનું, અહીંનું મેગ્નેટિક ફિલ્ડ ઇક્વેટ. આ જો બે સેમ હોય તો આ ડિસ્ટન્સનું રિલેશન શું? અહીંયા DA કહો ને અહીંયા DE કહો. So this DA અને DE વચ્ચેનું રિલેશન શું? તો આ છે 2 raised to 1/3 ટાઈમ. આ વધારે ડિસ્ટન્સ હશે કારણ કે 2 ટાઈમ્સ વડે મલ્ટીપલ થાય. અહીંયા આગળ 2 નથી હોતો કારણ કે ફોર્મ્યુલામાં 2 નથી, અહીંયા 2 વડે મલ્ટીપલ થાય. ઓકે. તો આ એક રિલેશન યાદ રાખજો વેર યુ ગેટ ધ સેમ મેગ્નેટિક ફિલ્ડ. અહીંયા પોઈન્ટ અને અહીંયા પોઈન્ટ મેગ્નેટિક ફિલ્ડ સેમ હોય તો બે વચ્ચે રિલેશન શું હોય? તો DA is equal to DE 2 raised to 1/3. Okay. A short bar magnet or magnetic moment 5.25 into 10 raised to minus 2 joule second. So magnetic moment is given by 5.25 into 10 raised to minus 2 joule per Tesla. Is placed with its axis perpendicular to Earth's magnetic field direction.
At what distance from the center of the magnet the resultant field incline at 45 degree with Earth magnetic field? So I draw the figure. I stop for some time to save the data. So question is, at what distance from the center of the magnet the resultant field is inclined with 45 degree? આનો અર્થ શું થાય કે પહેલા હું અહીંયાની વાત કરું, બાયસેક્ટરની વાત કરું. Okay, this is bisector. So this is Earth magnetic field, and this is a magnetic field of the magnet, and this is Earth magnetic field. If both are equal, the resultant is here. So if both are equal, then you will get the 45 degree. Similarly here also, this is magnetic field of the magnet, this Earth magnetic, both are equal, then this is 45 degree. So ટૂંકમાં મારે શું કરવાનું છે? I have to find out the point where I get magnetic field of the magnet equal to the Earth magnetic field. Okay, so I write the point where magnetic field of magnet equal to Earth magnetic field. Both are mutually perpendicular. Then we get resultant with an angle 45 degree with B of Earth. Okay, આવું મારે શોધી કાઢવાનું. So first possibility I take on axis. Axis માટેનું point હું શોધું. પહેલા કઈ કીધું છે મને નથી ખબર. ના પહેલા bisector છે. This is B case છે. So perpendicular bisector. First I take perpendicular bisector. So I use the formula B on equatorial line is equal to 0.42 Gauss is equal to mu 0 upon 4 pi into m upon dq. Okay, so I get this dq. I write here. Therefore dq will be equal to mu 0 upon 4 pi into m upon 0.42 Gauss. So I convert into Tesla minus 4. So mu 0 is 4 pi into 10 raised to minus 7. M is given, and it is 0.42. Oh, sorry. M is not 42. M is 5.25 into 10 raised to minus 2. 5.25 into 10 raised to minus 2 divided by 4 pi into 0.42 into 10 raised to minus 4. So I have to simplify this. So this comes out 4 pi cancelled out. This is 10 raised to minus 7 minus 2 plus 4. This divided by this. So જે આપણી પાસે આવે છે, that I write it down. It comes out to be 12.5. 12.5 આવી જાય છે. So this is 12.5 into 10 raised to minus 5. So I want to take the cube root. So what I do, I convert this number so I can divide by 3. So I write in minus 6. I am making smaller value. So I have to make larger value, 125. So dq. And if you take the cube root, then it comes out with 5 into 10 raised to minus 2. That is 5 centimeter. Yes, 5 centimeter. It is 5 centimeter. Okay. This is on equatorial line. So this value for equatorial line. Now same field I want to get it on the axis. So just now I will discuss what is the relation between these two. So D on the axis is equal to 2 raised to cube root times distance on equator, where you get the same magnetic field. તમે calculation भी કરી શકો. This is 1.26 into 5. So you are getting it around 6.3 centimeter. This is in centimeter. Okay, where you get magnetic field equal to 0.42 Gauss. એટલે મને અહીંયા 42 Gauss મળશે, અહીંયા 0.42 મળશે. This is in this direction. Sorry. Yes. So this resultant is making 45 degree. તમે જાણો છો બે વેક્ટર છે, perpendicular છે, તેનો resultant 45 degree હશે કારણ કે magnitude same છે. Okay. The next one, this is some discrete type, so at present I'm not discussing this. Calculative wala karo. Okay. A long straight horizontal cable carries a current 2.5 ampere in the direction 10 degrees south of west to 10 degrees north of east. First I prepare the figure, so time tomorrow bache. So a long straight horizontal cable carries current 2.5. So I is equal to 2.5 ampere. In the direction 10 degrees south of west. South of west, એટલે west છે અને south એટલે આ બાજુ 10 degree. એવી રીતે north of east એટલે આ બી 10 degree જ હોય. એટલે આ રીતે કરંટ આમ જાય છે. આવી રીતે. And I try to show here also. આવી રીતે બતાવવા માંગ્યું છે. So this is your cable, this is your cable. આ બી બે સેમ છે. આ top view છે અને આ side view થી બતાવું છું. Okay. Here magnetic field is 0.30. Deep angle is not there. So everywhere magnetic field કેટલું છે? Parallel to this one હોય. આ magnetic meridian છે, dotted line. This black line magnetic meridian. 10 degree west છે. એટલે આ બાજુ west, north west. So this is magnetic meridian, this is magnetic meridian. So magnetic field line હંમેશા આવી રીતે હશે. Always parallel to this. So magnetic field ને જો draw કરું તો આવી થાય. This is magnetic field lines. Sorry. This is magnetic field line. આ રીતે. Okay, parallel to the magnetic meridian. And the direction is page ની અંદર તરફ જાય એ રીતે. Page ની અંદર તરફ જાય એ રીતે. Inside. So here also magnetic field direction is like this. Okay. હવે આનું magnetic field ક્યાં હોય? If you take this is your current carrying conductor, તો એનું magnetic field thumb રાખવાનું, તો field is like this. So નીચે for lower part goes inside, so it means in the direction of the earth magnetic field. ઉપરથી બહાર આવશે. તો ત્યાં opposite થશે. So you will get null point above the cable. સમજો બરાબર. અર્થનું magnetic field તમારી બાજુ છે. અહીંયા બી તમારી બાજુ છે. જ્યારે કેબલનું magnetic field નીચે તરફ તમારી બાજુ છે, toward you, but upper point toward me. So both are subtracted at the upper point. So here you get the magnetic field 0, where it is called null point. So this distance suppose D. આ top view છે એટલે આની ઉપર આવશે, કેબલની ઉપર આવશે. આ કેબલની ઉપરનું point છે. Don't confuse. So this distance it is, so we have formula. So I write using right hand thumb rule, the direction of magnetic field of cable can be determined. It will be in circular shape, that is sure, circular shape. below the cable fill will be toward north, while above cable it will be toward south. Magnetic field of Earth, magnetic field of Earth is toward north everywhere. Everywhere. So null point will be above cable. Let us say at distance d. હવે આપણે formula use કરીએ. B is equal to, what is the formula of the magnetic field? Because of the cable, તો mu 0 I upon 2 pi y for long y. યાદ કરી લ્યો, અહીંયા d આપણે કીધું છે. So d, and therefore મારે calculation એની કરવાની છે. Cable is equal to, locate the, means you have to find out d. So d is equal to mu 0 I upon 2 pi b, 4 pi into 10 raised to minus 7. I is, I think, 2.5 ampere. 2.5 ampere, yes. 2 pi into b, that is 0.33 Gauss. 33 Gauss, sorry. So I convert into Tesla minus 4. So 4 pi means this cancel, so 2. So 2 into 2.5 upon 0.33 into minus 7 plus 4. So 10 raised to minus 3. So this is 5 by, I think it is 15 into 10 raised to minus 3. Okay. 5 and 1 by 3. So I think it's okay. That is in meter. So you can say that it is at 1.5 centimeter. Yes, 1.5 centimeter. So please students, be careful about the direction. Again I tell you, this is the cable in this direction. Sorry, this cable in this direction. So field is like this and earth magnetic field like this. તો ઉપર શું થશે? સબસ્ટ્રેક્શન થશે, નીચે એડિશન થશે. તો field null point will be above the cable. અહીંયા જો પૂછ્યું હોય તો field is downward. Field is downward. Earth field is here. So I have to take vector addition of these two. So it will be root 2 times earth magnetic field. અહીંયા આ point પાસે. આ point પાસે બી એટલું થશે. અહીંયા આગળ subtraction એટલે 0. અહીંયા આગળ addition એટલે double. So here double, here 0, root 2 times, root 2 times. તમારી સાઈડમાં કરું તો આવી રીતે ફીલ છે. અર્થનું ફીલ આમ થાય છે. તો પેલું અહીં સબસ્ટ્રેક્ટ થાય, ઉપર સબસ્ટ્રેક્ટ થાય, અહીંયા એડ થાય, અહીંયા આગળ root 2 times થાય, અહીંયા આગળ root 2 times થાય. Okay. So this is your question. Today's 3 magnets of length 5 cm, 10 cm, 15 cm are of equal magnetic moment M, placed as shown in the a plane as shown in the figure. What will be the resultant magnetic moment? Assist me, what is the resultant magnetic moment? એ તમારા આન્સર આપવાનો છે. Okay. So telephone cable at a place has 4 long straight horizontal wires carrying a current 1 ampere in the same direction east to west. The Earth's magnetic field at the place is 0.39 Gauss and the angle of dip is 35 degree. The magnetic declination is nearly 0. What are the resultant magnetic field at point 4 centimeter below the cable. 4 centimeter below the cable. At a telephone cable at a place has 4 long straight wires. Carries current 1 ampere in the same direction, east to west. So these are the 4 cables. Suppose I take 4 cables. Okay. It's made of 4 cable mani liye apne, and this is your east side, this is your west side. Okay. The earth magnetic field at a point 0.39 Gauss and its deep is 35 degree. The magnetic declination is 0. So here I is equal to 35 degree and magnetic field of the earth is equal to 0.39 Gauss. What are the resultant magnetic field at point 4 centimeter below the cable? So this is the 4 centimeter. I go down. So current is flowing in which direction? East to west. So if you take thumb this direction, the field will be in outward direction. And here it is inward direction. Okay. And earth magnetic field is also going inside, એટલે કે north તરફ જાય છે. North અને પાછળના ભાગમાં થાય. So inside એટલે both will be adding. But there is a declination. Sorry, deep is 35. તો એનું જે ફીલ હશે અર્થનું ફીલ હું સાઈડમાંથી જોઉં તો કેવું દેખાશે? આ રીતે દેખાશે. So this is the BE અને મારે આ કમ્પોનન્ટ લેવાનો થાય. This is HE and this angle is I. અહીંયાથી નીચેની તરફ હશે, હા, નીચેની તરફ, અને આ કોમ્પોનન્ટ કયો થશે? HE. તો મારે કેલ્ક્યુલેશન કરવાની છે what is the magnetic field at that point. અંદર તરફ કીધું ને, going inside, so I made mistake here. Inward, I write a different color, inward. And this is your, this dot is here, this is dot, downward. So this is HE. So મારું resultant field કેટલું થશે? This field is magnetic field of the cable and this is inside, downwards. તો આ જે અંદરની સાઈડ કીધું HE થશે. તો resultant will be B is outward and inward કયું છે? HE. What is HE? તો કે BE cos I. The magnetic field of cable below the cable will be towards south. હું સાઉથ કહી દઉં છું. and earth magnetic field everywhere toward north side, north, but it is inclined down due to deep angle. So horizontal component toward north, HE is equal to BE cos I. So BE is given, I think, 0.39 Gauss into cos I. I is 35 degree. I don't know 35 degree, so I have to find the value of that. Point. So this is 0.819. So 0.39 into 0.819. So this is the Gauss of horizontal component. Now magnetic field of cable એની મારે કેલ્ક્યુલેશન કરવાની. So that I say suppose B of cable is equal to mu 0 I upon 2 pi y. Okay. So we have 4 cables, so I multiply by the 4. So 4 into 4 pi into 10 raised to minus 7 into current is equal to 1 ampere divided by 2 pi and below 4 centimeters, so 0.04. So if you simplify this, 2 pi cancel, so I get 2. This is a 4 cancel, so it becomes 100. So I think 200 into 10 raised to minus 7. Okay. So I convert into 200 into 10 raised to minus 4 into 10 raised to minus 3. So this comes out to be, this is, I remove this, so it becomes cos. So 0.2 Gauss. This is B of the cable. So B બાર આવે છે, પેલું HE અંદર તરફ છે. So resultant field is equal to B means HE. કોણ મોટું છે? This is I have to multiply. So this is larger one. HE is larger one. So HE minus B of cable. So this is a multiplication of that 2. આપણે calculation કરેલું છે તે 0.39 into 0.81. 0.39 into 81. 0.39 into 0.819 equal to 0.31. 0.319 minus 0.2. So this around comes out to be 0.119. I hope so. Everything correct. So it's okay. It is 0.12 around cos. Okay. મળી ગયું એટલું? બીજું શું કરવાનું છે? What is the result magnetic field at 0.4 centimeter below આવી ગયું. So we find out so horizontal component એ કેટલો થશે? તો હું એને નામ આપી દઉં BH is equal to this product of these two. This is horizontal component of the earth and minus this value of the cable. So 0.39 into 0.39 into 0.819 minus 0.2. So that comes out to be 0.12 cos. That is this one. And this is the still is the original component. Earth magnetic field vertical તો છે જ, એ બી મારે શોધવું પડશે. And now you have two components, then resultant is square of this plus square of this, then you take the square root. એટલે થોડુંક વિચારવું પડશે તમારે. Okay. Now vertical component of BE, that is called ZE is equal to BE sin I. What is BE? So 0.39 into sin 33 degree. તો એ કેટલું આવશે એ મારે જોવું પડશે. તો એ આવશે 0.22. 0.22 cos. તો હવે એવું થયું, this is a BH. એ કેટલું કયું હતું? This value. And this is the ZE. because of cable this is change, otherwise અહીંયા શું મારે લેવાનું હોય છે HE, શું લેવાનું હોય છે HE, but now HE changed because of the cable, so this is now resultant. અને B અર્થ નથી કહેતો હું હવે, તો B is equal to root of ZE square plus BH square, so root of 0.22 square plus 0.12 square. So if you simplify all this, you are getting 0.25 cos. That is the magnetic field because of the presence of all these things. સમજમાં આવ્યું? થોડું વિચારી લેજો. જો કેબલ ના હોત, if cable is not there, તો હું સાઈડમાં બતાવવા માંગુ છું. This is the earth magnetic field, this is your HE and this is your ZE. હવે કેબલને કારણે શું થાય છે, મેગ્નેટિક ફિલ્ડ બહાર આવ્યું, તો આજે આ બાજુનું HE હતું એમાં થોડું ડિક્રીઝ થયું, ડિક્રીઝ થઈને કેટલું થઈ ગયું 0.12 થઈ ગયું, અને આજે ZE તો હતું એનું ઈ છે, તો આનું સ્ક્વેર પ્લસ આનું સ્ક્વેર મારે કરવાનું, દેટ ઇઝ ધ રિઝલ્ટન્ટ મેગ્નેટિક ફિલ્ડ. બે વાર વિચારવું પડશે પછી તમે કરી શકશો. યુ કેન ફાઇન્ડ ધ થીટા ઓલ્સો, તમે થીટા બી શોધી શકો આની મદદથી કે tan થીટા now new I मतलब, तो B V means this is ZE, vertical component ZE and horizontal component is BH. So ZE is 0.22 divided by 0.12, so you can simplify, you can get the theta also. Okay.